welcome to 2 + 2 = Cabbage. In this video, we're going to talk about how to deploy a Palo Alto firewall to AWS with Terraform. We'll go over some of the things like the code, we'll talk about GitHub, we'll talk about route tables and how they're important in this scenario, look over a little bit of the Palo Alto basics, and then in the end, we'll test to make sure our firewall is deployed correctly by using an RDP session to a Windows VM that's behind a NAT on the firewall. Let's figure it out together. All right, let's dive in. So here we are at our GitHub page, 2 + 2 Cabbage, and this is where you'll find all the sample code for the different projects that we do. In today's video, we're going to be working with AWS and Palo Alto, and we've got our link here, Terraform AWS Palo Alto base. This is everything we'll be using to deploy to AWS with Terraform. Instructions here, there's the README, kind of walks you through the steps, and then all the different files are here. So clone this locally, and this is where you'll jump off from, and we'll jump over now to look at these in VS Code and highlight some things that we want to focus on where we're seeing some differences between some of the different providers. All right, let's take a look at our Terraform code here. We're in VS Code, and we've grabbed the code from GitHub, and we're just jumping in now to see some of the things in here that might be of interest, some things that are different if you watch some of the other videos of AWS, Azure, or OCI, some things that might change. But the basic starting point we have for all of these is establishing our credentials file. Includes everything we need to log in. In our case, we've got a terraform.tfvars.template file. And you'll take this and you'll populate it with the correct information for your environment. Keeping in mind some of these are just for identification purposes and others are critical, like the access key, secret key, things like that you need from your actual AWS instance, and you'll save it as terraform.tfvars, removing the .template from the end, and then Terraform will pick that up as your authentication file to use when you do your apply. Our locals file, this just outlines some of the naming conventions that we use, just makes things a little bit more consistent throughout the environment so we can recognize things by sight when we see them in the AWS console. AWS networking, this is where we set up all of our base networking. So we've got our VPC, we defined our VPC CIDR block, which is the large subnet that we will use, and we'll carve that up into different subnets for our use. So we've got a management subnet, we've got an untrust subnet, which is the one that faces the internet, and the trust subnet, which is where our private workloads will reside. In our case, we'll have a Windows VM sitting in the trust subnet that we can use to test connectivity. We've got an internet gateway, and that's how we get the environment access to the internet. And via that internet gateway, we'll leverage the routing static, which is the file that contains our route table. So we've got a public route table, which basically says go straight to the internet if you want. We would only assign that to the subnets for the untrust of the firewall and the management interface because we need to be able to access those over the internet directly. The trust route table, we want to make sure we're pointing it to the trust interface of the firewall. So we want to make sure that that trust subnet cannot get to the internet if it's not going through the firewall first. And down below here, we've got the associations that just show which subnets we're associating with which route table. We've also got security groups because we want to make sure for those public-facing interfaces like the firewall management interface specifically, we want to make sure we control access to that. So what we've done is we've created the rules here so we can only access the management interface from my public IP, which is you'll put your own public IP in there so that way you're restricting access and nobody else can get to it. We're less concerned with outbound traffic. For this use case, we'll just let it talk to the internet however it wants to. And then the untrust interface of the firewall, we're also allowing that to talk to the internet because we're protecting our network with this firewall, so that's okay. And the trust subnet, we're doing pretty much the same thing. It's bound by its routing to only go through the firewall, so it can't talk to the internet directly anyway. So this is just for testing purposes. This is okay to leave it wide open. And then our firewall.tf, this is everything that we use to construct the Palo Alto firewall instance. So we're defining the network interfaces. So we've got management, untrust, trust. We're putting IPs on here, so it's easy to identify. We know exactly what's what. We're not going and trying to find what DHCP address was given out. We've also got public IPs, which are assigned to the management interface and the untrust interface, so they can talk to the internet and have inbound traffic on them. And here we're building the actual Palo Alto firewall instance. And this incorporates things from elsewhere, including some of the naming templates, some of the variable templates. We do have the AMI for the Palo Alto firewall defined in our variables. And we've got interface attachments. And then at the end, we're outputting the public IPs of the firewall, so it's easy to just grab them and copy them. We'll need them in the future, so we'll want to pay attention to what those are, and then we can make use of them. But that's all we really need to review here. So let's jump into getting the Terraform to commit. So we're going to always start off with Terraform init. That builds our local environment, make sure we have everything downloaded and ready to actually push the Terraform configuration to AWS. This will take a minute. Okay, that finished. And if we look up on our folder structure on the left, we see that it created the .terraform folder and the .terraform.lock.htcl file. So those are some things that happen when we run init. Now we'll run Terraform plan. And Terraform plan goes through and validates the configuration, and it basically tells you everything it's going to do without actually committing it to AWS. And that ran through pretty quick. And that's just going through, and if you scroll up, you can see the different things that it explains. You know, we're creating different components, and then at the end it says we're going to add 23 things, not changing anything, not destroying anything, because nothing is out there already. And then it outputs the private IP of the VM, the management IP, and the untrust IP of the firewall. And I like to run the plan just because it shows me what it's going to do. You could always skip running Terraform plan and just go straight to Terraform apply. But sometimes you'll identify some problems or things with the plan rather than waiting for it to try to apply, because the apply sometimes takes a little bit longer, and it may just take a little bit longer for you to even just get an error back. All right, Terraform apply, and we'll let this run for a minute. And we've got to type yes to make it keep going. All right, the apply to AWS takes place pretty quickly with this configuration. So we're pretty much done our first stage of deployment here. One thing we'll need to do, so we've got a Windows VM and a Palo Alto firewall VM. The Windows VM will boot up pretty quickly, but we do still need to wait for that to boot up. The Palo Alto VM will take a little bit longer to boot up. So what we'll do is we'll switch over here to the AWS console. We can see how things were set up out there, look around, maybe look at the status of the Palo Alto VM, and then we'll come back out of that and we'll move on to the next phase after it's deployed and ready to go. All right, we're in the AWS console here. We've logged in and ready to start poking around. There's a few places that we'll look. We'll look at the EC2 to see our instance, and we'll look at the VPC. I've already got shortcuts here for myself. If you don't have shortcuts, you can just type in EC2 or VPC if you want to get to those blades. So we're going to start with VPC. This is where we'll take a look at the networking that we set up. And as we can see here, we've got our VPCs, or VPC in the East US region, and we can click on VPCs just to see that. And we can see our naming convention here, makes it easy to identify the ones that we've created. Shows the CIDR. This is the complete subnet block that we can use. We can carve that up for different subnets. Down under subnets, we should have our three. We've got trust, untrust, and management. And those subnet IPs are over here. Each one's a /24. Route tables. We created our default and trust route tables here. We can click into them, see details, so we can see the routes. Default route here is pointing to the ENI of the trust interface of the firewall, so that's good. The other thing that we'll look at is the internet gateways. This is our path to the internet. So this just is some of the components we need: VPC, subnets, route tables, internet gateways. If we wanted to look at security groups, we've got them down here. And we've got the trust, untrusted management security groups that we created all right in this area. That's pretty much it for the VPCs. Let's go over to EC2, where we can have a look at our instances. Right here under instances. And we've got two. We've got the firewall that we created. This is the Palo Alto firewall. Everything looks good. It's running by now. We've let it sit for a little while, so it's running and ready to go. We've got the our Windows instance that we'll use just for testing when we're done. One thing we can do, if you're waiting around for your VM to boot, we can click into the instance ID here. We'll look at the firewall. And then under the actions menu, we can go to monitor and troubleshoot and get instance screenshot. This is handy if you're waiting for something to boot up and you don't know its current status. When the Palo Alto firewall is booting, it'll just look like a Linux instance is booting. Once it gets to the VM login, as you see right here, it populated a bunch of other things from the console, but the relevant part here is it says VM login. Normally it would just say VM login and it would be a prompt. You wouldn't have all this other junk, but as it sits there for a while, some of the things get logged to the console, so that's why we see all this stuff. But this tells us that the VM is booted and should be pretty much ready to go. Sometimes you might see it get to VM login and then you try to log into it via SSH or something and it still doesn't quite work. Give it a few more minutes and it'll probably start to work pretty quickly after that. And then back at the instances list, while we're here, we'll just go into the Windows instance and we'll grab the password that was set in there. One difference here in AWS is we have to get the password from within the console. We can't set it through Terraform. So we'll just go over here and grab that password. So we clicked on the instance, went over to Actions, Security, Get Windows Password. And here again, we need the key that we created. It's the same key that we use for publishing with Terraform. It's the same key we use to log in to SSH on the firewall. So we're just going to go find that key. The key gets populated, hit decrypt password, and then we're just going to copy this off to a text file, and we'll have it handy for when we're ready to log into our Windows instance. That's all we need to do in the AWS console. So now we're ready to go and try our SSH session to our Palo Alto firewall, change the admin password, and then we can keep moving along. Okay, so with the Palo Alto VM booted and ready for us to log in, the first thing we need to do is log in and change the admin password so then we can use the web interface, and we'll get to that a little bit later. The one thing that's different if you're comparing, for example, Azure to AWS, in Azure, when we deploy the VM, we can just log in directly with the username and password that we set during the deployment. With AWS, we need to use the key that we used. In this case, we're using the same key that we used to authenticate to AWS to deploy the Terraform altogether. So same key. So you already have that from when you created your credentials. And what we're going to do here is at a command prompt. So I'm in Linux here, and we're just using command line SSH. So SSH-I, and we're going to use the key that we already have, which I have right in the folder here with me. And that's the key that I'm using for this. And then we're just going to say the username by default is admin at, and then I've got to go from my notes and grab the IP that we have from the output of Terraform, or if we look for it in the management console, and it's just the public management IP that we're going to use here. So this is the command, and it should reach out and try to SSH. The first time we're connecting, it doesn't recognize the key, so we're just going to say yes, go ahead and accept the key. And now we are logged in. It doesn't ask for a password when you use a key, so we are right here directly at the command line of the Palo Alto firewall. So the next thing we're going to do is we're going to change the admin password because there isn't really one presently, or if it was, it would be the default, which is admin. And in this context, it doesn't work, so we need to create a new password. So we'll just do configure, puts us into configuration mode, and then we can do the additional commands that we need to do. And the command for setting the admin password is just set management config users admin password. And you can type the password after this if you want, or you can hit enter and then it'll prompt you for the password and you can enter it that way. So we'll just enter it and confirm it. So that password is in there. Now this takes effect right away. So if you went and logged in to the web interface now, the new password would work. And if you happen to reboot the firewall without committing it, that password wouldn't be saved. So we want to make sure we commit here. All right, the commit completed successfully. So we're pretty well done here at the CLI. The next thing we'll go and look at is the web interface, and we'll see how the interface works, and we'll import the configuration, and we'll keep moving in that direction. Before we go over to the web interface and look at the Palo Alto firewall, there's one more bit that we need to look at in the code. And within our download of the code we have from GitHub, we have the firewall config. And this has everything we need to import into the firewall as far as configuration to make everything work. But one thing that we want to do in here is we want to go in and do a find and replace so we can add your public IP into the file. So all we're going to do is do Control H, we're going to do find, and the IP address that we want to search for that's in here is 5.5.5.5. It'll be in here twice, and all we're going to do is replace that with our public IP, save the file, and then we'll be good to go. And in the next step, I'll show you how to import that into the Palo Alto configuration within the web interface. Now we're ready for the web interface, and we can just put the management IP address that we got from the Terraform output into the address bar with HTTPS, and it'll probably alert you that it's not a secure web page. So depending on the browser that you're using, you may need to just bypass the certificate check to get to the page. We're just testing here, so we haven't uploaded a legitimate certificate for this. And we're going to log in with the username and password that we added at the command line. Give it a second to log in. And we can close the prompts that pop up at the beginning. We don't have to do anything with those right now. And we're logged in right now. So we've got everything accessible here so we can upload our configuration and we can get going with testing. So we're going to go to the device tab and we're going to go under setup and operations. We're going to import a named configuration snapshot, and that configuration snapshot is within the GitHub under the firewall configs folder. And once we put that in there, this is normal for it to say cfake path. It does that in Palo Alto by default. It doesn't really show you the complete path here. We'll click OK and close. The import has simply loaded the file into the firewall storage, so it hasn't made it active yet. So what we need to do is go into load named configuration snapshot, and we'll browse to the one that we uploaded, which is firewall-config, and click OK. So now the configuration is being loaded into memory. It's still not active on the firewall, but it's, of the 3 steps to make it active, the import, the load, and then commit, we're at 2 out of 3. So the configuration is there now, so we can go and we can look at policies and things like that and see that they have been imported, so they're present, they weren't there before. But now we'll just hit commit, and we will let that run, and it'll activate it on the firewall. And one thing we'll see here is it seems to be stuck at 99%, and that's pretty normal. When you upload a new configuration into a firewall, there's changes that sometimes the browser, um, I don't want to say rejects, but it needs to be refreshed so you can actually log in again with the new configuration. So we're just going to hit refresh. 99% is usually, if it sticks there for a minute, then you know it's just waiting and it needs to be refreshed to let you log back in. And we'll log in again here. In this case, the configuration that we uploaded has the admin username as FWAdmin, so we just need to use that with the password, and we can log in. And we're back, logged in as FWAdmin, and there's nothing else we need to do in here for the purposes of our demo, but just for interest of seeing what's in here. So we do have our policies defined, so we're allowing traffic to the RDP host, which is going to be Windows. It's only allowing it from my public IP, which you set in the config file before you uploaded it. Some general things to allow testing traffic like ping and things like that. And then the other important thing is the NAT. So we're natting the inbound traffic from the internet so that we can get to that Windows instance. And that's all we need to really look at here on the GUI console for the firewall. So the next thing we're going to do is test our Windows VM to see if we can RDP to it. We're ready to try to RDP into our Windows client that we have running. So it's behind the firewall, so we're going to use the untrust IP address of the firewall that was part of the output in Terraform when we applied the configuration. So this is the IP here, and we're just going to hit connect. And the default username is administrator. We're just going to put in the password that we copied off or a little bit earlier from the console. Hit OK. And it's just saying, the name of the computer doesn't match the IP you're connected to. That's fine. We're just doing this for testing. And we can see we've got ourselves logged in. Windows looks fine, normal. Let's open up a web browser. Make sure we can go to a website that we like, and everything seems to work fine. So we've gone through and done everything up to this point. We got our firewall running. We know we're getting through it to get to our Windows VM, which is cool. Now we just need to go back to VS Code, clean things up, and we'll be done. We're back in VS Code, and we've done everything we wanted to do with the project. We looked through the GitHub. We went through and looked at the code here in VS Code. Talked about some things that are a little bit different in AWS. We deployed. We checked our firewall to make sure it worked. We uploaded the configuration, tested to make sure we can get through to the Windows VM. So everything seems to work just fine. The last thing we need to do is clean up our mess, and we want to do that so we don't get charged for things in AWS that we don't expect. So very simply here, we're just going to do Terraform destroy. And this goes through our configuration and removes everything that we put into AWS. Doesn't touch anything that may have been there previously. It only knows about things that are within its configuration. So we're safe in doing this, and it should go and clean things up nicely. We're typing yes, we want you to go ahead and destroy, and let it go. All right, we're finished with our deployment and destroyment. So we're good. Everything worked the way we expected. The config is sound. So stay tuned for future projects. We're going to do some more stuff with AWS, GCP, OCI, Azure, things like that. Use the comments section to add ideas or comments, good or bad, and stay tuned for future episodes. Thanks for visiting 2 + 2 = Cabbage. If you found this video useful, like and subscribe to show me there are people out there who would like to see more of this content.